The Voyager 1 spacecraft, launched by NASA on September 5, 1977, is the most distant human-made object ever to travel through space. It has now crossed into interstellar space, far beyond the boundaries of our solar system, and continues to send back valuable data about regions of space we've never before explored. Its mission was originally planned to last only 4 years, but here it is, over 45 years later, still operating and sending back information. Voyager 1's continued survival is a testament to the ingenuity and innovation of the engineers and scientists behind it, as well as the durability of its design. Voyager 1's journey began as part of the twin Voyager spacecraft program, which aimed to take advantage of a unique planetary alignment that only occurred once every 176 years. The alignment of Jupiter, Saturn, Uranus, and Neptune provided a rare opportunity to send 2 spacecraft on a gravitational slingshot through the outer solar system. This gravity assist maneuver would allow the spacecraft to travel faster and more efficiently than ever before, enabling them to explore Jupiter and Saturn and then continue on their way out of the solar system. However, the Voyagers weren't just exploring the outer planets, they were tasked with the grander mission of exploring the boundaries of our solar system and beyond. The Voyager program would push the limits of human exploration to places previously unimaginable. Their discoveries would change our understanding of space and time, of the cosmos and our place in it. The origins of the Voyager missions. The Voyager program was conceived in the early 1970s, when NASA scientists began to realize that a unique planetary alignment was coming up in the next decade. The gravitational pull of the gas giants Jupiter, Saturn, Uranus, and Neptune would allow a spacecraft to slingshot around them, gaining speed and energy in a way that had never been attempted before. This alignment offered an unprecedented opportunity to study the outer planets, and the decision was made to launch 2 spacecraft, Voyager 1 and Voyager 2, to take advantage of the rare opportunity. The Voyager missions were the brainchild of Gary Flandreau, a NASA scientist working at the Jet Propulsion Laboratory (JPL). Flandreau's genius lay in his ability to calculate the perfect trajectory for the spacecraft to take advantage of this cosmic alignment. Using a pencil, paper, and rudimentary computing tools of the time, Flandreau worked out the optimal paths that would allow the spacecraft to visit Jupiter, Saturn, Uranus, and Neptune, all while taking advantage of the gravitational pull of these planets to accelerate their journey. Flandreau's calculations proved to be spot on. The 2 spacecraft, launched in the summer of 1977, just 15 days apart, would embark on a journey through the solar system, gaining speed as they passed close to each of the gas giants. The gravity of each planet would act like an invisible rope, pulling the spacecraft forward and slingshotting them on their way. This gravity assist technique allowed the Voyager spacecraft to travel faster and more efficiently than any spacecraft before them. Voyager 1 was originally tasked with exploring Jupiter and Saturn, while Voyager 2 was designed to study all 4 of the gas giants. The 2 spacecraft carried identical scientific instruments, including cameras, spectrometers, and magnetometers, designed to study the planets, their moons, and the surrounding space environment. But what neither mission planners nor scientists expected was just how long these spacecraft would last, nor the incredible discoveries they would make. The surprising longevity of Voyager 1. When Voyager 1 was launched, its mission was expected to last just 4 years, enough time to visit Jupiter and Saturn and send back valuable data. However, Voyager 1 defied all expectations. The spacecraft successfully completed its primary mission, sending back stunning images of the gas giant planets and their moons, and then continued to function long after its primary mission had ended. As Voyager 1 traveled farther from the Sun, the spacecraft's energy needs grew more challenging. To conserve power, NASA engineers shut down non-essential systems, and the spacecraft began to rely on its onboard computers to make critical decisions. The spacecraft's computers were primitive by today's standards, only 69 kilobytes of memory, far less than a modern smartphone, but they were designed to operate autonomously in the vast emptiness of space. In fact, the probes were so advanced for their time that they carried out all of their operations independently, sending back data and adjusting to new challenges as they arose. One of the most astonishing aspects of the Voyager missions was the technology they employed. Despite being launched in the late 1970s, the spacecraft continued to send data back to Earth using technology that was outdated even when they were launched. The spacecraft used a radio transmitter to send data back to Earth at a rate of just 160 bits per second, about the same speed as dial-up internet. The data was transmitted using a 12-foot wide dish antenna, which allowed the spacecraft to communicate with Earth over vast distances. But communication with Earth became increasingly difficult as Voyager 1 ventured farther and farther from the Sun. The spacecraft's signals had to travel through space for longer periods, and the strength of the signal diminished with each passing year. Signals from Voyager 1 now take more than 21 hours to reach Earth, and the spacecraft's data transmission rate has decreased dramatically. Nevertheless, Voyager 1 continues to send valuable scientific data about the interstellar medium, the space between the stars, and the conditions at the farthest reaches of our solar system. Voyager's surprising discoveries. Even after completing its initial mission, Voyager 1 continued to make unexpected and groundbreaking discoveries. The spacecraft's close flybys of Jupiter and Saturn revealed new details about these gas giants and their moons. For example, Voyager 1 captured stunning images of Jupiter's Great Red Spot, the massive storm that has been raging for centuries, and it discovered active volcanoes on Io, one of Jupiter's moons. This discovery was groundbreaking, as scientists had long suspected that the moons of the gas giants could be geologically active, but the images from Voyager 1 confirmed it in spectacular fashion. In addition to its images, Voyager 1's scientific instruments also provided valuable data about the atmospheres of Jupiter and Saturn, as well as their magnetic fields. One of the most important discoveries from Voyager 1's visit to Jupiter was the detection of Jupiter's strong magnetic field, which had never been observed before. This discovery provided scientists with critical information about the gas giant's internal structure and the way its magnetosphere interacts with the solar wind. Voyager 1's flyby of Saturn also yielded incredible data. The spacecraft sent back detailed images of Saturn's rings, revealing their intricate structure and the gaps between them. Voyager 1 also provided valuable data about Saturn's moons, including Titan, the largest of Saturn's moons, which was later visited by the Cassini spacecraft. Titan, with its thick, nitrogen-rich atmosphere, is now considered one of the most intriguing targets for future exploration. But perhaps the most significant discoveries from Voyager 1 came after it passed through the outer planets and continued its journey into the unknown. As Voyager 1 traveled beyond the gas giants, it began to encounter regions of space that had never been studied before. The spacecraft's instruments detected an increase in cosmic rays, high-energy particles that travel at nearly the speed of light, and changes in the interstellar magnetic field. These findings were key to understanding the boundary between our solar system and the vast emptiness of interstellar space. In 2012, Voyager 1 made history by becoming the first human-made object to cross the boundary of the heliosphere, the bubble of charged particles that surrounds the solar system, created by the Sun's magnetic field. This marked the beginning of Voyager 1's journey into interstellar space. However, this transition was not as dramatic as scientists had expected. Although they had anticipated a sharp increase in cosmic rays and a dramatic shift in the magnetic field, Voyager 1's data showed a more gradual change. The challenges of interstellar communication. As Voyager 1 moves farther into interstellar space, communicating with Earth has become increasingly difficult. The spacecraft's signals have to travel for more than 21 hours before they reach Earth, and the signals are weaker than ever. In addition, background noise from Earth caused by everything from radio stations to cell phones makes it harder to pick up the signals from the spacecraft. Despite these challenges, the Voyager team continues to receive valuable data from the spacecraft. The spacecraft's instruments continue to measure the density of particles in the interstellar medium, and Voyager 1 is also providing insights into the magnetic field of the interstellar space it is now traversing. These findings have deepened our understanding of the vast space between stars and the environment beyond our solar system. The future of Voyager 1. As Voyager 1 continues its journey through interstellar space, it will eventually run out of power. The spacecraft is powered by a thermoelectric generator that converts heat from the decay of plutonium into electricity. However, as the spacecraft moves farther from the Sun, the generator's power output decreases. NASA engineers have already turned off non-essential systems to conserve power, and they will continue to do so as the spacecraft nears the end of its operational life. Despite these limitations, Voyager 1's journey is far from over. The spacecraft will continue to travel through interstellar space, sending back valuable data until its power is exhausted. Even after it stops transmitting, Voyager 1 will continue to drift through the vast expanse of space, a silent testament to humanity's quest for knowledge and exploration. In the coming decades, Voyager 1 will move farther and farther from Earth, eventually crossing the boundary between our solar system and the Oort cloud, a vast, icy region that surrounds our solar system. Though Voyager 1 will never reach another star system, its legacy will live on as a symbol of humanity's reach for the stars. Voyager 1 and the spirit of exploration. The story of Voyager 1 is not just one of scientific discovery, it is a story of humanity's endless curiosity and desire to explore the unknown. Voyager 1 has shown us that with ingenuity and determination, we can overcome the limitations of technology and explore the farthest reaches of space. It has reminded us that the universe is vast and full of mysteries waiting to be uncovered, and that the spirit of discovery can carry us beyond the stars. In a way, Voyager 1 is a message from humanity to the universe, carrying a gold record that contains sounds and images of Earth meant to represent the diversity of life and culture on our planet. As it drifts through space, Voyager first may one day be discovered by an alien civilization, an emissary from Earth, carrying the hope of human exploration across the cosmos. The Voyager missions have expanded the boundaries of human knowledge, reshaped our view of the universe, and inspired future generations to continue the search for answers to the greatest questions of our existence. With the Voyagers still transmitting data after more than 4 decades, they remind us that exploration is not bound by time or technology. It is a fundamental part of our nature, and one that will continue to drive us to explore the farthest reaches of space for generations to come.